Right, capacitors are components that you'd find in circuit boards, like resistors. You can use them a little bit like a battery, because what they do is they store charge. And so they enable you to use that stored charge to run the circuit. This is what they look like. If you've ever opened up the back of an electronic device, you'll probably see that these are all wired up next to all the other components. A simple diagram of a capacitor would be two plates. And inside those two plates, you have an insulating material. What's curious about this component is that because there's an insulator, the current does not actually flow across the capacitor. In a way, a capacitor is like a break in the circuit, because once the current arrives, it can't flow through to the other side. Let's have a look at it more closely. Most capacitors are rolled up tightly into a ball like this one. That's what gives it its cylindrical shape that you see above. The larger they are, the more charge they can hold. And you have a metal plate, which I can show on the simplified model here. These are your metal conducting plates, but in reality they're rolled up like this. And then in between those metal plates you have the insulator, which is called a dielectric material. You don't need to know that, just thought it would be useful. Here is your dielectric material in between the conducting plates. You only need to be familiar with this kind of representation, the simplified version of the capacitor. To sum up, a capacitor stores charge. And this is a good representation of what it looks like. Again, to consider how it works, we need to think about having a switch in this circuit. Imagine the switch was switched on so that the circuit was closed. As you can see, this negative terminal would release electrons that would rush onto this plate and, oops, there's nowhere for them to go. Why? Because the dielectric is an insulator. So the electrons accumulate until there's so many of them on here, they start to repel any of the arriving ones. So in fact, the circuit stops working. On this side, you have an absence of electrons and a positively charged plate, until it becomes so positive that any escaping electrons will eventually be pulled back and the circuit stops flowing. This could happen in a matter of microseconds or seconds, depending on the capacitor that you're using. So, your capacitor ensures that as soon as you switch on the switch, the circuit stops flowing within a couple of seconds. What use is that? Well, you have a nice charge stored across one of these plates. So if you were to now get rid of this battery and close the switch again, the electrons will redistribute themselves. Let me show you that a little bit more clearly. If you were to now close this switch again, make the circuit complete, these electrons which are surplus here would then flow all the way round again to balance out the positive charge. So in the same way as before, you had like a surge of current until the capacitor charged up. When you remove the power supply and close the switch, this time you have another surge, but this time of discharge. Okay? Now, the symbol, as it's something you would put in a circuit, the symbol for a capacitor looks like this. If anything, you would have to recognize it rather than to place it inside a circuit yourself. Of course, there has to be some maths in here somewhere, so let's have a look at this quantity, capacitance is defined as the ratio of charge stored to the applied potential difference. Ignore that I. Another way of looking at it is the charge per unit potential difference that can accumulate on a conductor. The units are coulombs per unit volt or the farad. Very commonly, you do sometimes see the picofarad, which is times 10 to the minus 12, or microfarad, etc. Okay, so that's all you need to know about capacitance. And just to clear it up again, if we have a look in a circuit, you usually have a capacitor with some capacitance stated, a resistor in the circuit through which the capacitor can discharge, a switch, and there may or may not be a power supply. Now, when you're resolving questions, should you get a question on capacitance, it's important to treat the capacitor just like a battery. So if you know what the capacitance is and the charge stored, you just have to find the potential difference and use that potential difference to calculate anything that you need to calculate in the circuit, like the current, for example.